from 33.3 e to negative 0.5 t dt. Perfect. Awesome. Thank you so much. The constant is waiting patiently outside. For something like this, we established the step. We don't need to use a substitution. So we have 33.3. And now what function prime is this?
It's just e from negative 0.5 t.
Divided by 0.5?
Yes, exactly. Thank you so much. So remember we established this a long time ago. The integral from e to a constant times t, or x, or doesn't matter the variable, e to a constant times the variable is e to that constant, of course, e to that divided by negative 0.5. When you differentiate this, you will get that. Guaranteed. This function prime is this function. So now we plug in 5. I will remove the negative 0.5. It can wait patiently outside. I plug in 5, e to negative 2.5 minus e to 0, which is 1. So I plug this in the calculator because this is not, we're talking about divorces, the total number of divorces, so I can't just say, hey, calculate this, that's the number, right? So we have to determine this. So we had negative 33.3 divided by 0.5. I need to put it in parentheses. Sorry, I didn't start with parentheses. Okay. And then again parentheses. And it's e raised to negative 0.25, negative 2.5, sorry. And then minus 1. When I hit enter, if I get a negative number, there will be a tragedy. Because I can't have negative number, total number of divorces, right? So that will be a big mistake somewhere. So let's click on enter. So 61 total per 1,000 people. So now if you want to check, we can. I didn't mean that. It's so fidgety. But I did click on enter though. So be careful how you enter this. So 33.3 and then e raised to power negative 0.5x. So when I click enter, I have to get the 61 blah 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 blah. So that's it. Now I want to come back to what we discussed for a minute ago, because I want you to understand that the fundamental theorem of calculus does not work if the function is not continuous. So remember what I picked, 1 divided by x and dx. When I click enter, what do you think the calculator will scream back at me?
Error.
Error. It should say you lost your mind, lady. Okay? Not possible. But if I change this, let's say, I know. Okay, if I change this into, I don't know, 4, and I change this into positive 3, I didn't mean that, I meant, let's say 3 or 2, it will give us an answer, because 0 is not between 2 and 4, and it will not scream at me, it will give me the correct answer. Okay, so please keep that in mind. Okay, back here. Back here. Okay, then estimate the total number of divorces in Texas between 2015 and 2020 is the same. So that was approximately, I should write this answer here, 61 per 1,000 people. And the other one, part B, between 2015 and 2020. Would you tell me how would you determine that? Anyone?
With the interval from was it 5 to 10 instead?
5 to 10, from 33.3 e to negative 0.5 t dt. So in order to continue and just move on, because I know you know how to do this now. Okay, all I need to do is go back here. Why is that? Okay, so this is 5 now, and this is 10. Okay, so it's 5 per 1,000 people. Good. Anything else you would like to go back to? Anything else? Do you want to work on other integrals, or we move on? So this is my page 5.
We can move on.
Okay. Anyone else?
We can move on.
Okay. Perfect. Thank you. If you find something else, MyLab Math or otherwise, please bring it to class. So we start chapter 5 today. Chapter 5 is basically deals with applications of integration now, right? We just talked about integrating or finding definite and indefinite integrals. So these are applications, so there are only two, 5.1 and 5.7. We only covered 2 sections in chapter 5. In 5.1, we are going to look at only one item. There are other items in there, other applications, but we are going to look at only one. Consumer and producer surplus. My mind was already on surplus, that's why I put S instead of C. And this one is called differential equations. Equations that have derivatives in them. Okay? So hopefully we accomplish this tonight. So consumer and producer surplus. Okay. A long time ago, we talked about the equilibrium point. The equilibrium point. And we said that if we graph.
So your screen is kind of blurry.
Oh. Does anyone else confirm that?
Yes, I was just about to say something.
Okay, so the only option I have is